Let me challenge you. Can you check if two numbers are equal? Without using double equals. No comparisons. No shortcuts. Just pure logic. Sounds impossible? Let's see. Yes, we need to think like a computer. Computers don't actually see numbers. They see bits. For example, 5 is 101. 3 is 011. Everything is just zeros and ones. And there's one powerful operator that works directly on bits. XOR. Now here's the magic rule. If two bits are the same, the result is 0. If two bits are different, the result is 1. So what happens when both numbers are exactly the same? Every single bit cancels out. And the final result becomes 0. Let's see it clearly. 101x or 101 gives 000. That's the key idea. So here's the trick. If a x or b equals 0, then both numbers are equal. Simple as that. Let's write the code. Define a function. Return a x or b equals 0. That's it. No comparison operator needed. Now let's test it. 5x or 5 gives 0, correct. 5x or 3 gives 6, not 0. So it works perfectly. Imagine you have an array. And one number is repeated. Can you find it without using extra space? No sorting. No hash maps. Just pure bit magic. You are given numbers from 1 to n. But one number is duplicated. Your task is to find it efficiently. The input is 1, 3, 4, 2, 2. The output should be 2. Brute force. Compare every pair. But that is O(n) squared. Too slow. A nested loop checking every combination is way too inefficient for large inputs. Use a hash set. Track scene numbers. If a number is already in the set, we found a duplicate. But this uses extra space. Space complexity is O(n). Now comes the genius trick. XOR. Watch what happens when you XOR a number with itself. The result is 0. That is the key to solving this problem. XOR has three powerful properties. Property 1, a XOR a equals 0. Any number XORed with itself cancels out. Property 2, a XOR 0 equals a. Property 3, a XOR b equals b XOR a. The commutative property means order does not matter. We XOR all array elements. 1 XOR 3 XOR 4 XOR 2 XOR 2. Then we XOR numbers from 1 to n. 1 XOR 2 XOR 3 XOR 4. Combine both. Everything cancels out. Except the duplicate. The result is 2. Pause and try it yourself. Can you implement this XOR solution? Give it a shot before seeing the code. Let us implement this in Python. Define a function called findDuplicate. Initialize result to 0. Loop through each number in the array and XOR it with result. Then loop from 1 to the length of the array and XOR each index with result. Finally return the result. The output is 2. Same logic in Java. Create a main method. Define an integer array. Initialize residential to 0. Use a for each loop to XOR each element. Then loop from 1 to array length and XOR each. Print the result. Same logic. Same elegance. Different syntax. Time complexity is O(n). Single pass through the array. Space complexity is O(1). No extra memory needed. This is the optimal solution. This works only when numbers are from 1 to n, and exactly one duplicate exists. For other cases, You will need different approaches like Floyd's cycle detection or binary search. This is the kind of trick asked in top tech interviews. If you want more mind-blowing coding tricks, hit subscribe now. Let us go.